Your hand jerks back from a hot stove before you even register the heat. Your foot slams the brake before you consciously see the car ahead. Your heart is already pounding before your brain has finished the sentence, "Wait, is that a spider?" Something in you moves first. It decides first. And only afterward does the rest of you catch up, breathless, asking what just happened. That gap is not a glitch. It is the oldest survival system you own. Here is the strange part. The part of your brain that panics is not the part that thinks. It never learned language. It cannot read a warning label or reason through a risk. It only knows one thing, threat or no threat. And for most of human history, that single blunt instinct was the difference between walking home and never walking again. So what is actually happening in that split second before fear becomes a thought? Deep in your skull sits a small almond-shaped cluster of neurons called the amygdala. Almond-shaped, which is exactly where its name comes from. Neuroscientist Joseph LeDoux spent decades mapping how this structure works, and what he found rewired how we understand fear itself. Your eyes and ears do not send danger signals straight to your thinking brain first. They send a copy straight to the amygdala. LeDoux called this the low road, a shortcut that skips conscious analysis entirely. A slower path, the high road, does eventually reach your thinking cortex where you actually recognize what you saw. But by then, your amygdala has already sounded the alarm. Your heart rate has already spiked. Your muscles are already loaded and ready to move. You do not decide to be afraid. You are afraid first, and the deciding comes later. Think about how strange that really is. In almost every other part of your life, you assume you are in charge. You choose what to eat. You choose what to say. You choose, or at least believe you choose, how to react to the world around you. But in the exact moments when the stakes are highest, when something might genuinely be dangerous, that sense of choice quietly disappears. Something older than you takes the wheel first and asks permission later if it asks at all. Why would evolution build something so trigger-happy? Because in the ancient world, the cost of being wrong was never symmetrical. Imagine a rustle in tall grass. It could be wind. It could be a leopard. If you freeze and it was only wind, you lose nothing. If you assume it is wind and it was a leopard, you lose everything. Your ancestors who hesitated to check, who wanted more evidence before reacting, simply were not around long enough to pass that hesitation on. The nervous ones survived. The calm ones sometimes did not. This is what evolutionary psychiatrist Randolph Nesse calls the smoke detector principle. A smoke detector that only ever screams during real fires is actually a badly designed smoke detector. It is too slow, too cautious, tuned for accuracy instead of speed. A good smoke detector goes off too often on purpose, because a false alarm costs you a few seconds of annoyance, while a missed fire costs you your life. Your fear response is built on exactly that same logic. It would rather embarrass you 100 times than fail to warn you once. That is why you flinch at a garden hose coiled like a snake. That is why a shadow at the edge of a parking lot can spike your pulse before you even register what you are looking at. Your body is not being irrational. It is running code that was optimized for a world with far more teeth in it than the one you live in now. Consider what that ancient world actually demanded of your ancestors, day after day, for roughly 200,000 years. No walls that could not be climbed. No locks. No streetlights. Every walk to find water was a walk through territory that something else also claimed. A rustle behind you might be a troop mate. It might be a predator that had been stalking you since sunrise, patient enough to wait for exactly this moment when you were tired, distracted, alone. Under those conditions, a nervous system that reacted instantly and asked questions later was not paranoid. It was simply accurate to the world it lived in. The humans who are your direct ancestors, every single one of them without exception, survived long enough to reproduce partly because their bodies refused to wait for certainty before reacting to a possible threat. But here is where it gets stranger. Not all fears are learned equally fast, and that difference reveals just how deep this ancient wiring goes. Psychologists Arne Ertman and Susan Meinke ran a now-famous set of experiments comparing how quickly humans and primates learn to fear different objects. Show people images of snakes or spiders paired with something unpleasant, and the fear sticks almost instantly, sometimes after a single exposure. Show them images of guns or knives or electrical outlets, paired with the exact same unpleasant stimulus, and the fear takes far longer to form if it forms at all. Yet statistically, in the world you actually live in, cars and electrical sockets are far more dangerous than snakes will ever be. Your brain does not update its fear list based on modern statistics. It updates based on ancient priorities. It is still braced for a world of venom and claws, not a world of traffic and wiring. Later researchers pushed this even further, testing infants who had never had a single bad experience with either snakes or flowers. Even very young children orient toward images of snakes faster than they orient toward neutral objects, long before language, long before anyone could have taught them to be afraid. That is not a lesson passed down by a worried parent. That is a template already sitting in the wiring, waiting for the world to confirm it. So your amygdala is, in a sense, running on outdated software. Brilliant software for the savannah. Frequently mismatched for a cubicle, a group chat, or a crowded elevator. Because that is the twist. This same ancient alarm system that once fired for lions now fires for things that were never trying to kill you at all. A tense email from your boss. A silence after you send a text. Standing up to speak in front of a room full of strangers. None of these can physically hurt you, and yet your amygdala treats them with the same urgency it once reserved for a predator crouched in the grass. Your palms sweat. Your chest tightens. Your mind goes blank because blood is being redirected away from careful thought and toward your muscles, preparing you to run from a threat that is not actually chasing you. Notice what your body actually does during that moment. Your heart rate climbs, pushing oxygen toward muscles that are not going to be used. Your digestion slows because there is no evolutionary reason to spend energy breaking down lunch while a predator might be closing in. Your peripheral vision can even narrow slightly, a phenomenon sometimes called tunnel vision, useful when you need to focus everything on a single charging threat, less useful when you are simply trying to answer a question in a meeting. None of these responses were designed with meetings in mind. They were designed for a world where the only two outcomes of a genuine threat were survive or do not, and every ounce of energy needed to go toward the first option. Neuroendocrinologist Robert Sapolsky spent years studying this mismatch in his research on stress physiology, much of it built on long-term observation of wild baboon troops. Sapolsky's core finding was almost darkly funny once you sit with it. A zebra's stress response switches off the moment the lion is gone. It grazes again within minutes, as if nothing happened, because for a zebra, nothing is happening anymore. Humans are different. We can trigger the exact same biological alarm just by replaying an argument in our heads at 2 in the morning, lion nowhere in sight. Your body cannot tell the difference between a real predator and a remembered one. The stress hormones flood your system either way. This is why modern anxiety so often feels physical before it feels psychological. The racing heart, the shallow breath, the urge to either fight, flee, or freeze completely, even when the danger is only a thought. And the zebra never has to unlearn anything, because its body never mistakes memory for danger in the first place. Yours does, constantly. You can lie perfectly still in bed, muscles tense, jaw clenched, heart hammering, replaying a conversation that ended hours ago, and your amygdala will respond as if that conversation is happening again, right now in the room with you. It cannot tell time. It cannot tell the difference between a memory and a threat standing in front of you. It only knows that something registered as dangerous, and dangerous things get the same emergency response no matter when they occurred. This is also why chronic modern stress does something that acute ancient danger rarely did. A burst of fear on the savannah was almost always followed by resolution. You escaped, or you did not, and either way, the alarm eventually turned off. A notification, a deadline, a strained relationship, none of these resolve the way a fleeing predator does. The threat lingers in your imagination long after any real danger has passed, which means the alarm system built for short, sharp bursts of adrenaline is instead left running for hours, sometimes for years. Which brings you back to that gap, the one between your hand flinching and your mind catching up. That gap is not a flaw in your design. It is a feature copied down through hundreds of thousands of years, refined by every ancestor who reacted a half-second faster than the threat could reach them. Every time your pulse spikes at a shadow that turns out to be nothing, you are witnessing a system doing exactly what it evolved to do, protecting a version of you that no longer exists in a world that has mostly stopped needing it. Your body still panics before your mind does, not because something is wrong with you, but because for nearly all of human history, that panic was the only thing standing between your ancestors and the dark. And somewhere back there, in the tall grass, in the rustle that might have been wind or might have been teeth, that panic was right just often enough to still be sitting inside you today, waiting quietly for the next rustle in the grass.